to the channel. My next video is related to the third part of this chapter. Already in the previous videos we have discussed about acid and bases, their properties, their preparation, their classification and also their strength. And especially in the previous video I have discussed about the pH of the solution, which have lots of importance in our everyday life. So good morning to all. So today's video is related to salt, that is the third part of this chapter. So first of all we will start from the definition of salt. Okay, what do you mean by the salt? How can you define a salt? Means we are using so many salt, but how can we define those salts? Salt generally we mean that the common salt which we are using in cooking, but not like that. There are many salts are there. So what is the common definition of salt? So it is clearly written here. It is a compound formed by a partial or total replacement of hydrogen ion by metal ion. So once again I am repeating this definition, that whenever we will take any compound which is formed by a partial or total replacement, means either it partially the hydrogen ion is removed or completely the hydrogen ion is removed by the metal ion, that is known as the what? That is known as salt. So for example, if we will take the case of NaOH and H2SO4. Okay, so this is a base and this is a acid. We already discussed that this is a base and this is a acid. So this is the metal ion, that is the sodium metal. We know that this is the comes under group 1 element and this is the most reactive element, potassium and sodium. So sodium will replace hydrogen, because here it is told that partial or total replacement of hydrogen ion by metal ion. So this metal ion when replaced one of the hydrogen atom, then it will form NaHSO4 and remaining it forms H2O. So here what we can see, that there are two hydrogen is there, in which one of the hydrogen is replaced by sodium and it forms sodium hydrogen sulfate. So here there is partial replacement. Clear? So according to the definition, it is a compound formed by a partial replacement of hydrogen ion by metal ion. So here we can say the metal ion is partially replacing among two hydrogen, it replaces one hydrogen and forms sodium hydrogen sulfate, which is a salt. Similarly, the same reaction, if we will write like this, NaOH plus H2SO4, it completely replaces the hydrogen, means this sodium metal completely replaces the hydrogen, then it will forms Na2SO4. So when it replaces both the hydrogen, then also we are getting a salt, that is the sodium sulfate, and water as a byproduct. So here we can say there is complete replacement of what? The hydrogen ion by the metal ion. Complete replacement of the hydrogen ion by the metal ion. So by this two we can explain this definition of salt, that it is a compound formed by a partial or total replacement of hydrogen ion by the metal ion. So whatever compound is formed by the replacement of what? By the replacement of hydrogen by the metal ion is known as salt. So these two are the example of salt. Clear? So this is the definition. In another way we can explain the salt, that is the salt in the form of ions. Suppose we are taking NaCl. Okay, so when we are taking NaCl, in that case what will happen, when in aqueous solution or in molten state, molten or aqueous, molten means the liquid state of the compound, aqueous means in the water. what will happen? They are giving two ions. One is positive ion, another it will give the negative ion. So the positive ion is called as the cation and the negative ion is called as the anion. So generally what happens? The salts are ionic in nature. The salts are ionic in nature. It means they will furnish ions in the aqueous or molten state. They furnish ions in the aqueous or molten state. That is the definition of ionic compound. So salts are generally ionic compound. Salts are generally ionic compound. So ionic compound means, what do you mean by ionic compound? Ionic compound means they are giving ions. They are giving ions in molten or aqueous state. So here the molten, the positive ion in molten state, the positive ion is cation and the negative ion is anion. But what is the speciality of salt? The cation is positive but except hydrogen ion. Except hydrogen ion. Except hydrogen ion means the salt do not possess H plus ion. It possesses all the positive ions, but it do not possess the H plus ion. It do not possess the H plus ion. Similarly, the anion possesses all the negative ion except hydroxide ion. Except hydroxide ion. Clear? So we know that acid possesses H plus ion, bases possess what? Bases possess negative hydroxide ion. That's why what is the speciality of salt? Salt possesses positive and negative ion. Why? Because salt is ionic in nature. Salt is ionic in nature. So that's why it possesses the two types of ions. One is cation and another is anion. But what is the speciality of salt? That cation may be any positive ion except hydrogen ion. It do not possess hydrogen ion. It can possess Na plus, it can possess K plus, it can possess Ca2 plus, Mg2 plus, but it will not possess H plus ion. Similarly, when we will talk about anion, it will possess any negative ion except the hydroxide ion. Except the hydroxide ion. So we can say that the compound which possess positive or negative ion, cation and anion, other than hydrogen ion and the hydroxide ion, is known as salt. Clear? Means the compound which possess positive and negative ion other than H plus and OH minus ion is known as salt. Means the salt will only possess cation and anion other than H plus and OH minus ion. It will not possess hydrogen ion or the hydroxide ion. Clear? So by this two we can now say what is salt. You can easily distinguish between acid, bases and salt. Which one is salt, which one is acid, which one is base, we can distinguish by these definitions and by this ionic equations. Clear? Next we will discuss about the general properties of salt. General properties of salt. Clear? So what is the general property? First term is that electrovalent. First term is the electrovalent. Remember, compounds are formed by two ways. Either donating or accepting the electron, donating or gaining the electron. Suppose I am talking about, suppose tomorrow we have to show 10 projects. Okay, two students are there, both of them have to show the 10 projects. One student prepared 11 project, one student prepared 9 project. Okay, two students are there, one student prepared 11 project, another student prepared 9 project, but both of them have to show 10 projects. So what they will do, one of the boy which having 11, he having one extra project, so he donate one project to the second boy. So he donate one project to the second boy. Now both are having 10. So here what happened, one has donated the project, one has accepted the project. So now both are having 10 projects. Okay. So that is called as the electrovalent. Means when one of the atom is donating the electron and one of the atom is gaining the electron. Clear? Second is the covalent. Electrovalent. Similarly there is covalent. Covalent. So what is covalent? Covalent means, suppose both of them to show 10 projects, but they will not go at a time. They will not go to the teachers at a time. So both of them has prepared 9 projects. Okay, so when the first boy entered to the teacher's room, at that time he has taken his 9 project plus 1 project from that student. 1 project from that student. He shown the 10 projects. When the second boy entered, he take his 9 project as well as 1 project from the other student. So what they are doing? They are sharing one project. They are sharing one project to complete their 10 projects. To complete their 10 projects, they are sharing one project. So whenever the electrons are shared, they are forming covalent bond. Whenever the electrons are shared, they are forming covalent bond. Clear? So what is electrovalent bond? Electrovalent means whenever one of the atom is donating the electron and one of the atom is taking the electron or gaining the electron, that is called as the electrovalent. So since they are electrovalent means they are ionic in nature. Electrovalent, for example, Na+ by donating electron it becomes Na+, Cl- by gaining electron it becomes Cl-. So they are electrovalent in nature. Next is they are conducting in molten or aqueous state. In solid state they do not dissociate into ion. In solid state they do not dissociate into ions. But when they are converted into molten state or in aqueous solution, they are dissociate into ions. They are dissociate into ions. So in molten or aqueous state, the compound are dissociating into the ions. That's why they are conducting in molten or aqueous state. Conducting means it conduct electricity in molten or aqueous state. Why? Because in aqueous or molten state they dissociate into ions and this ion conduct electricity. Next is the next property. Before going to the next property, I am telling you the compounds are 2 types. One is volatile, another is non-volatile. Okay, so what is volatile, what is non-volatile? The compound which can be easily converted from solid to liquid, liquid to gas, that is called as the at normal temperatures. Those are called as the volatile compound. And the substance which cannot be converted from solid to liquid or liquid to gas at normal temperature, those are called as non-volatile. These compounds are generally non-volatile. These compounds are generally non-volatile. They cannot be easily converted from solid to liquid or liquid to gas. That's why they are having high melting point and boiling point. High melting point and boiling point. Hence, they are having high melting point and boiling point. And remember, these salts are also forming crystals. Means which are non-volatile compounds, those are generally exist in crystal form. So what is crystal? The 3-dimensional arrangement of the atoms or ions. Generally ions, ionic compound is there, it means ions. The 3-dimensional arrangement of ions in a particular geometry is known as crystal. So since they are non-volatile, means they are having high melting point and boiling point, that's why they are forming crystals. That's why they are forming crystals. So the third property is the solubility. Third property is the solubility. So how can we say the solubility? Generally the salts are soluble in water. But it depends. Soluble in water, but it depends. Depend on what? It depends upon temperature and amount. So generally the solubility, salts are ionic in compound, and we know that water is a ionic solvent. Because in a solution there are 2 things are there, solute and solvent. Which is present in less quantity, that is called as solute, and which is present in more quantity, that is called as solvent. Which is present in less quantity, that component is called as the solute, and the component which is present in large quantity, that is called as solvent. So generally water is a ionic solvent and salts are ionic solute. So that's why they are soluble in water. They are soluble in water, but it depends upon their temperature and as well as it depends upon the amount. For example, I am showing you, suppose there is 1 gram in 100 ml of water at 298 Kelvin temperature, means normal room temperature, 298 Kelvin temperature, then it completely soluble. Clear? So whenever 1 gram of solute is dissolved in 100 ml of water at 298 Kelvin temperature, it completely soluble. But if we are taking in between 0.1 to 1 gram, in between 0.1 to 1 gram, same composition in 100 ml of water at 298 Kelvin temperature, they are partially soluble. And when it is less than 0.1, okay, less than 0.1, I am writing it here, less than 0.1 gram, at that time it is insoluble. Remaining parameters are same, 100 ml of water, 298 Kelvin temperature, but the amount is less than 0.1 gram, at that time it is insoluble. If it is in between 0.1 to 1 gram, they are partially soluble. Partially means half of them is soluble, half is insoluble. But when it is greater than 1 gram or greater than 1 gram, at that time it is completely soluble. Clear? So this is the third property, that is the solubility. Last property is the hydrolysis of salt. Hydrolysis of salt. Okay, so what is the hydrolysis of salt? Okay, suppose we are taking any salt and we are soluble in water. Any salt we will take and soluble in water. What will be the product? And so whenever the salt is mixed with water, that is called as the hydrolysis of salt. For example, we are taking Na2CO3. When we are dissolving in water, they are giving back what? They are giving NaOH plus what? H2CO3. Okay, so they are giving NaOH, H2CO3. So generally we know that H2CO3, it is a weak acid. H2CO3 is a weak acid and NaOH is a strong base. It is a strong base and this is a weak acid, because already I have told you in mineral acid only the carbonic acid is the weak acid. So it is a weak acid, is a strong base. So that's why this salt is basic salt. Similarly, if we will take the case of CH3COONA, this is sodium acetate. When dissolved in water, they are also giving acetic acid, that is CH3COOH plus NaOH. So again, this is a weak acid and this is a strong base. So this salt is basic in nature. So we can say that the salts are acidic as well as basic, or they are neutral. So it depends upon the strength of the acid and bases. So whenever the salts are hydrolyzed, they are giving acid and bases. Whenever the salts are hydrolyzed, they are giving back the acid and bases. So this is about the hydrolysis of